Let's talk about the different types of variables. So a variable can be either quantitative or qualitative. Now for quantitative variables, ratios and intervals have meaning. An example of a quantitative variable is a continuous quantitative variable. Now that variable could be measured to arbitrary precision, and examples of a continuous variable include price and temperature. On the other side, an example of a qualitative variable is a nominal variable. And here you have categories with no specific ordering. So examples include political affiliation and Cal ID number. And so if you think about it, there's no ordering associated with political affiliation, and similarly, there's no ordering associated with a Cal ID. Now, in terms of quantitative, you can have discrete variables. These have a finite set of values, and examples are number of siblings or years of education. In terms of qualitative variables, you can have ordinal variables, and these you have categories with levels, but there's no consistent meaning to the difference between those levels. So examples are preferences or level of education. Now, if you look at level of education, it could be, say, high school diploma, associate's, bachelor's degree, master's degree, PhD degree. There's a difference between PhD degree and master's degree, but that's not equivalent to the difference between, say, an associate's degree and a high school diploma. Now, it's important to note that categorical variables can have numeric levels. So you could have an ordinal variable that is, say, a movie rating. So you could have 1 to 5 stars, right? But again, the difference between, say, a 4-star rating and a 5-star rating is different from the difference between a 1-star rating and a 2-star rating. Quantitative variables, they're oftentimes stored as strings, and so you'll have to convert them to numbers as part of the data cleaning process. Okay, with that backgrounder behind us, let's look at what's the type of variable. So we have a choice between quantitative continuous, quantitative discrete, qualitative ordinal, and qualitative nominal. So let's start with carbon dioxide level measured as parts per million. So what type of variable is that? Think about that for a moment. So that variable is going to be quantitative continuous because we can measure it on a continuous scale. What about the number of siblings? Think about that for a moment. And here's a hint. I gave it away to you on the last slide. So that is going to be quantitative discrete. There's a finite set in terms of the number of siblings. What about grade point average? What type of variable is that? Again, think about that for a moment. So that will be quantitative continuous because ratios and intervals have meaning. Now, the next one is income bracket. So here I'm giving you labels low, medium, and high. So what type of variable is that? Think about it for a moment. Okay, so I didn't tell you what I mean by low, medium, and high, right? For example, low might be less than $10,000 per year, and medium might be $10,000 to $100,000 per year, and high might be over $100,000. So the levels might not be equivalent, and I'm just telling you a relative ordering, but I'm not telling you what they mean. And so that's going to be qualitative ordinal. What about race? What type of variable is that? Think about that for a moment. Okay, so that would be qualitative nominal. What about number of years of education? What type of variable will that be? So again, think about that for a moment. So that's going to be quantitative discrete. What about Yelp rating? What type of variable is that going to be? And here's a hint. I kind of gave it away on the last slide. So that will be qualitative ordinal. And again, think about it. The difference between a 4-star rating and a 5-star rating is different from the difference between a 1-star rating and a 2-star rating. And this is actually very important because a lot of times people try to build predictive models, right? They want to predict what is going to be your rating for a restaurant, so they can suggest a list of restaurants to you. Now, if they just assume that all of the ratings are equivalent, then they're going to mispredict which restaurants you might like. It's a little bit more work, but you can actually build models that do take these differences into account. So it's always important to start by thinking about what type of variable am I dealing with.